This is the program to find the roots of a quadratic equation. First thing is we have to understand what is the mathematical background behind this, and we have to draw the flowchart. Finally, we can possible to go for writing the program. Already we have understood what is the mathematical background behind this quadratic equation. Along with that, already we have drawn flowchart also. Now, third and final step is writing the program. Let us write this program using Python. This is Python. Let us follow the flowchart. Flowchart is like this. First thing is, in this example we have to find the square root of a number, so that let us import a package math. Next thing is, let us start from the beginning of flowchart. First step is read the values of a, b and c, so that through the print statement let us request to the user to enter coefficients of a quadratic equation. What is the next step? We have to read the values of a, b and c through the input function. Python read the data from the user in string format. That's what we have to split using split function. Then converts into float using typecast method. After that one, next step is we have to check it out whether that value of a is equal to 0 or not. So that if a is equal to 0, you can see here in flowchart a is equal to 0. If it is true, then we have to find the value of x using this expression. So that x is equal to minus c by b. There onwards, before going to display the value of x, characteristics of roots. Characteristics of roots are like this. Given coefficient forms a linear equation, so that only one solution. What is that solution? That solution is x value. That is root is equal to x. Here only let us execute this program. You can see here prompt is like this: enter coefficients of a quadratic equation. To execute this part, a value should be 0. So that let us enter 0. Simple values are 2 and 10. What is our expected result? Minus c by b means to say that minus 10 by 2. Minus 10 by 2 means to say that minus 5. You can see here root is equal to minus 5. We got the correct result. Next, let us move on to next part. If a is equal to 0, when it is false, then what? Then we have to find the value of d using this expression. In program, else we have to find the value of d using this expression. After finding the value of d, we have to check it out that value of d is greater than 0 or not. For that purpose, let us go for if statement. If d value is greater than 0, if it is true, then x1 is equal to like this, x2 is equal to this one. Then x1 is equal to this one, and then x2 is equal to this one. Before going to display the values of x1 and x2, first thing is let us display characteristics of roots. Characteristics of roots are like this. Roots are real and different. Then root 1 is equal to x1, root 2 is equal to x2. Here only let us execute once again. A value should not be 0, so that let us enter 1. D value should be positive, so that 4 and 1, and press enter key. You can see here roots are real and different. Roots are real and different. We got R1 and R2 values are like this. Then if d greater than 0 is false, then what? Once again we have to check the another condition using elif statement. D less than 0, when this condition is true, if d value less than 0, then we have to calculate Rp and Ip values. Rp is equal to this one, Ip is equal to this one. There onwards, R1 equals complex of Rp comma Ip, R2 equals complex of Rp comma minus Ip. Before going to display these two values, first thing is let us display using print statement characteristics of roots. Characteristics of roots are like this. Roots are complex and different, and root 1 is equal to R1, root 2 is equal to R2. Here only let us execute this program. Once again, a value should not be 0, so that let us go for simple values 1 1 1. Right now we are expecting complex number. You can see here we got roots are complex and different. Then let us move furthermore. If d value less than 0 is false, then we have to find x1 and x2 values using these two expressions. R1 equals R2 equals minus c by 2a. R1 is equivalent to R2, both are same, so that R1 equals R2 is equal to minus c by 2a. Before going to display the values of R1 and R2, let us display characteristics of roots. Characteristics of roots are like this. Roots are real and equal. Root 1 is equal to R1, root 2 is equal to R2. Let us execute once again. Once again, a value should not be equivalent to 0. 1, 2, 1. What is our expected result? Roots are real and equal. You can see here, roots are real and equal. R1 is equal to minus 0.5, R2 is equal to minus 0.5. Both are equal and real. Final program is like this. Please make a note of this program and execute yourself. Thank you. Thanks for being with us. Thank you. Thank you one and all.